Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The conversion of a carbonyl group, C is equal to O, to a methylene group, CH2, i.e., complete deoxygenation to give a hydrocarbon, requires a specific reaction that removes the oxygen entirely. Moving on to the next step. Identify what each reagent does to a carbonyl compound. A. H2PT, catalytic hydrogenation reduces a ketone aldehyde to an alcohol, C is equal to IChO, not to a hydrocarbon, CH2. It does not remove oxygen. B. Lyl4, a strong hydride reducing agent that reduces carbonyls to alcohols, C is equal to IChO. Again, oxygen remains in the product as an alcohol, so this does not give a hydrocarbon. C. N2H4KOH delta. This is the Wolff-Kishner reduction. The carbonyl compound first reacts with hydrazine, N2H4, to form a hydrazone, C is equal to NNH2, which upon heating with strong base, KOH, loses N2 and converts C is equal to O directly to CH2. The product is a hydrocarbon, oxygen is completely removed. D. K2Cr2O7H2SO4, this is an oxidizing agent. It would oxidize, not reduce, carbonyl compounds or alcohols further, giving carboxylic acids or other oxidized products. It cannot convert a carbonyl to a hydrocarbon. Moving on to the next step. The Wolff-Kishner reduction, N2H4KOH delta, is the classical method specifically designed to convert carbonyl groups, aldehydes and ketones, directly into hydrocarbons, CH2 or CH3, by complete removal of the oxygen atom. And for the final step, H2PT and Lyl4 only reduce to alcohols, retaining oxygen. K2Cr2O7H2SO4 is an oxidant, moving in the opposite direction. Only N2H4KOH delta, Wolff-Kishner reduction, achieves full deoxygenation to give a hydrocarbon. Therefore, the correct answer is C. Therefore, the correct answer is option C.